Welcome to the fastest way to learn data structures and algorithms with this premium revision material. Today, we are mastering LeetCode 290, the word pattern challenge. This is a fundamental string mapping problem that tests your understanding of bijections and hash maps. It is a common interview favorite for companies like Amazon and Google. Let us look at the problem statement. Given a pattern and a string S, we need to find if S follows the same pattern. Following the same pattern means there is a one-to-one mapping, or a bijection, between every letter in the pattern and every non-empty word in S. For example, if our pattern is A B B A dash, and S is dog cat cat dog, then A maps to dog, and B maps to cat. This is a perfect match. For our strategy, we will use two hash maps to track the relationship from both sides. One map links pattern characters to words, and the other links words back to characters. This ensures that no character maps to two different words, and no word maps to two different characters. Think of it like a professional ballroom dance. Every leader must have exactly one partner, and every follower must have exactly one partner. If a leader tries to dance with two followers, or a follower with two leaders, the pattern is broken. Let us dive into the dry run. Look at the screen. We have our pattern ABBA dash at the top, and our string S. Dog cat cat dog, which we split into 4 words. At the bottom, we have our two mapping tables. First, we look at the first character A and the first word dog. Neither is in our maps, so we create the link. A maps to dog, and dog maps back to a dash. Everything looks good. Next, we move to B and the word cat. Again, neither is mapped. We link B to cat, and cat back to B dash. The pattern continues. Now, we hit the third element. Another B and another cat. We check our maps. Does B map to cat? Yes. Does cat map to B dash? Yes. The relationship is consistent, so we move on. Finally, we reach the last pair. A and dog. We check our tables. Already maps to dog, and dog already maps back to a dash. The entire sequence matches perfectly. We return true. But what if the last word was fish instead of dog? When we reach the end, we would see that A is already mapped to dog, but the current word is fish. That is a mismatch, and we would return false immediately. Now, let us look at the Python code. We start by splitting the string S into a list of words. If the number of words does not match the length of our pattern, it is impossible to have a match, so we return false right away. We initialize 2 empty dictionaries, char to word, and word to char. We iterate through both the pattern and the words simultaneously using the zip function. Inside the loop, we check our conditions. If the current character is already in our map, but it does not map to the current word, we have a conflict. Similarly, if the word is already in its map, but maps to a different character, that is also a violation. If neither conflict exists, we store the mapping and continue. If we finish the loop without any issues, we have a valid pattern. Looking at the complexity, the time complexity is O of n, where n is the number of characters in the pattern, or words in the string. We traverse the input exactly once. The space complexity is also O of n, because in the worst case, we store every unique character and word in our hash maps. And that is the word pattern challenge, mastered. Save this video for your next technical interview, and follow Leo Academy for more such premium DSA guides.